Hi everybody, my name is Daniel from Blue Spark Innovations. Welcome to Blue Spark Innovations Energy Academy. Um, I hope you are following us. I've made video 1, video 2, and I think this is video 3. This is video 3, load analysis and calculations in solar installations. Please don't forget to like and subscribe to our channel. In this video, I'm going to be teaching you how to carry out basic load analysis and calculations in solar installation, either if you are a solar installer or you are an individual who wants to install a solar system at home. This video will help you personally so that even if your installer is carrying out some load analysis, you'll be able to understand what he or she is doing. So let's speak the words load and then analysis. So load here simply refers to the appliances. The appliances you intend to power, you want to be powered by your solar installation. And analysis simply refers to breaking down of this particular load. So when you bring the two terms together, it means that the process of breaking down the loads of the appliances that you actually need to be powered by your solar installation. Now, how can we explain this? Let's use an example. Let's say example. We have Mr. Gideon. Let's use Mr. Gideon. Mr. Gideon has let's see, one TV, one decoder, one laptop, 5 bulbs, and 4 charging ports. He wants to charge 4 phones. Let's say he's using fast chargers, 4 phone chargers. So what we want to do now is by load analysis, we want to analyze all these loads to be able to recommend an inverter system. And then in video 4, with this example, I will now show you how to design a solar system to fit this load. So let's move. What is the first step we need to take? Step 1. We need to create a table for the load. Create a load table. And how do we do that? Okay, I hope you can see what I'm saying. Create a load table. Now let's start with serial number, appliances, the quantity, then wattage, and then total wattage. Good. Now, 1. What is the first appliance? Our TV. It could be a flat screen TV. Usually, we know we live in a world where we use flat screen TV. So, let's say our flat screen TV is 1. Let's say the wattage is 120 watts. 120 watts. 1 times 120, the total wattage is what? 120 watts. Then the second item 2 is what? Decoder. How many decoders? 1. Let's say our decoder is 30 watts. It will be a DSTV decoder, a GoTV decoder. So averagely, let's just say 30 watts. That's 1 times 30, 30. What's the next item? Item 3, laptop. Let's say our laptop is 65 watts, or maybe it's a 60 watts laptop, you know, the how do you know the power rating of the laptop? You go to the back of that charger, the laptop charger. So let's say the laptop is let's say maybe he wants to use two laptops. Let's say two laptops. Let's just use two laptops. 60 watts, 60-watt laptop. That's 2 times 60. That's 120 watts. Then item 4, bulbs. You know, bulbs to light up the room. So how many bulbs do we have? We have 5 bulbs. And let's say each bulb is 26 watts. So that's 5 times 26, and that will give us 5 times 26 times 6, 30. That's 130 watts. Yes, I think I'm correct. 130 watts. And then the last thing is 4 phone chargers. Number 5, item 5, phone chargers. Phone chargers, that's 4 pieces of phone chargers. So let's say we are using fast chargers, which is 25 watts. 4 times 25, that's 100 watts. So now let's add everything up to have our total wattage. So 120 plus 30, that's 150. 150 plus 100, 250 plus 20, that's 270. 270 plus 100, 370 plus 30, 400 plus 100, everything gives us 500 watts. So now the total watts, total load power, and unit of power is watts, is what? 500 watts. So let PT is what? 500 watts. That is total power. So all the appliances Mr. Gideon wants to use on his solar system is what? 500 watts. I hope you understand. Now, what is step 2? I hope you've seen this. I'm going to clean this so that I'm going to write out step 2. Let's just take note that our PT, let's write it here. PT, total power, is what? 500 watts. For what? For the load. So let me clean this. Step 2. What is step 2? We need to convert this load power to kVA. Now, why do we need to do that? Let me write that. Convert load power to kVA. I will explain why we need to do this. Now, let me use this explanation. This is a cup. This is a cup. When you pour beer into this cup, remember when the beer settles, you always have your foam head at the top of your cup, and then you have your beer. This is your foam, and this is your beer. Now, in physics or electrical energy, right, this foam head here is what we call reactive power. Now, your beer, which is the main beer that you drink, is what we call, from here to here, is what we call true power. And now, the addition of your apparent of your reactive power and true power is what we call apparent power. I hope you're following me. Now, your apparent power is measured in kVA or VA. This is kilovolts ampere or volts ampere. Your true power is measured in watts or kilowatts. And then your reactive power is measured in volt ampere reactance, VAR. Now, for this illustration, what we need majorly is what? Your true power and your apparent power. You see, the reason why we need to convert this load power, which is in what? Your true power to apparent power, is for the fact that inverters are rated in kVA. I'll make another video to explain why inverters are rated in kVA, because you are adding your reactive power and your true power to give you what? Apparent power. So your inverter is working with both your reactive power and your true power. So your inverters are rated in kVA. So we need to convert this load 500 watts to what? To kVA. To compare it, to be able to know the value or the size of the inverter that we are going to use to carry this load. Am I making sense? I hope you get me. Now, remember this. 1000 watts will give you 1 kilowatts, and 1000 VA will give you 1 kVA. K stands for kilo, which is 1000. Now, how do we convert between kVA and kilowatts? We have a conversion formula for that, and formula is kilowatts over kVA is equal to what? 0.8. This is the conversion formula. Kilowatts over kVA divided by 0.8. Now, so we have 500 watts. We want to convert it to what? kVA. Remember, PT, which is 500 watts, if we convert it to kilowatts, it will divide it by 1000. Divide 500 by 1000, this is what? 0.5 kilowatts. So if we bring that into this formula, that is 0.5 kilowatts divided by kVA will give you what? 0.8. So in order for you to know kVA, let's cross multiply. So kVA, that means kVA now is what? 0.5 divided by 0.8. And that will give you 0.625 kVA. Which means that this power, PT, which is 500 watts, in true power is also equivalent to what? 0.625 kVA. In what? Apparent power. So we've known the value of the load in true power, which is 500 watts, and now we know the value in what? Apparent power, which is 0.625 kVA. Am I making sense? Now, what is the reason why we need to convert this to kVA? And like I said earlier, our inverters are measured in what? kVA. What is an inverter? An inverter is a device that converts energy in direct current found in batteries to alternating current, AC, that can power appliances like TV, decoder, laptops, and phone chargers. So in our setup in the solar installation, we are going to be needing an inverter. So we need to convert the load capacity from true power to apparent power to compare, to be able to know the size of the inverter we are going to use. So now, Now that we know the value, let me just clean this. Now that we know the value of our power in in kVA, we need to look for an inverter that can carry this load. How do I mean? Let me use something as an illustration. If you are driving a car, a sedan or a Lexus, just a normal car, and it stops working, you need to pull it across the road. If you bring another Lexus, the equivalent size of that car, and to pull it, it will actually pull it, but with some kind of stress. But what if you bring a truck? A truck will pull it successfully. Is that not so? So in the world of solar installation, we need an inverter that has a higher capacity that can actually carry the load. And in order to get this, we have something we call safety factor. We multiply the safety factor by this load capacity. So inverter size now will be what? Inverter size will be equal to safety factor multiplied by what? Load in what? kVA. And that is what? What is safety factor? Is a standard 1.2 multiplied by 0.625. Multiplied by 0.625, and that will give us 0.75 kVA. So our inverter size is what? 0.75 kVA. So a safe inverter that we can use is what? 0.75 kVA. Now, when you go to the market, I live in Nigeria. We have a place in Lagos where most of us buy, most installers we buy inverter from. We have Arena in Oshodi, and we have Ojo Alaba. That's the biggest market in Lagos where we buy solar cables and all those solar panels and inverter and stuff. When you get to Ojo Alaba and you want to buy an inverter, and you begin to tell them, my friend, Oga, how far? You get 0.75 kV inverter, they will look at you. That this person is a novice. Why? Because there is no inverter of 0.75 kV. The closest inverter you get to this is what? 1 kV inverter. 1 kVA inverter, which is a 12 volts inverter by standard. So in order for you to be able to power the load Mr. Gideon needs, you need a 1 kVA 12 volts inverter standard. So if you have a 1 kVA 12 volts inverter, you are good to go. There are some inverters that in Nigeria we call them sachet inverter. They are small inverter in aluminium cases. Some of them are rated 500 watts, 12 volts. You see 1000 watts, 12 volts. So, and you can find them on Amazon. So for this setup, you can easily use what? A 1000 watts, 12 volts inverter. So it's either you get a 1000 watts 12 volts inverter, or you look for a 1 kVA 12 volts inverter to carry this particular load. So the essence that I'm doing this calculation and showing you the basis is for you to understand how to make your own basic calculation on your own or as an installer for your client. So that is step 2. Now, let's go to step 3. I'm going to clean all this. Let's go to step 3. What is step 3? Step 3 is to calculate the backup time. How long will your inverter be able to power Mr. Gideon's load? You know, it's one of the questions your customers will ask you. This solar installation you want to do for me, how long is it going to last me? Now, I'm going to show you how to calculate, basically, how to calculate that time. That time, we call it runtime or backup time. RT, runtime or backup time, BT. So what is step 3? We want to do what? Calculate the runtime RT or / backup time. In order to do this, there's one thing you need to know. You know your inverters are powered by battery. You need to know the value of the battery you are using. So let's say, for example, we are using a 200 hour amps battery. So let's say using 200 amp hour batteries. Batteries, the units that they are measured in is what? Amp hour. I'll explain that subsequently when we get to batteries. So now, we've known our power, we've calculated our inverter value. Don't forget, we said we'll use a 1 kVA 12 volts inverter. You can either use this or use this. And we know our total power in load. Now, how do we calculate the backup time? So the backup time, there's a formula for it. RT or BT is equal to what? BV multiplied by BC over PT. Your BV is your battery voltage multiplied by what? Your battery capacity, which is 200 amps in this case, divided by what? Your total load. In what? True power. Don't forget, that is what? 500 watts. So let's calculate that. BV is what? 12 volts. We are using the 12 volts inverter. 12 multiplied by the capacity of the battery, 200, divided by what? The load in true power, 500. So this cancels, this cancels. 2 times 12, this is 24 divided by 5. So I don't want to use my calculator. Let's use the old school method. 24 in 5. 5 in 2 will not go. 5 in 24. 5 times 4 is 20. 4 times 5 is 20. 24 minus 20, that's 4. Let's put a dot here. By the way, in primary school, we used to call this chachangi motors. So let's put a dot here. Let's add 0. 5 in 40 is 8. 8 times 5 is what? 40. So we have our answer. Our answer is what? 4.8 hours. So it means that if you are using a 1 kVA inverter to power a 500 watt load on a 200 amp hour battery, it will last you for what? 4.8 hours. So if my customer asks me how to install this system and they ask me how long will it last, I won't say 4.8 hours, I will just say 4 hours. Why? Because customers can be funny. Remember, when the customer is using this load, if a neighbor comes in and says, Mr. Gideon, you're charging, you have light, you're charging, please can I add a laptop or can I add one more phone? Please can I charge my laptop with you? And they plug in a laptop. What happens to the total power? The total power has increased. When the total power increases, the total load power increases. What happens to the runtime? The runtime decreases. The more the power on the inverter, the lesser the runtime. So if Mr. Gideon does not use all this load at a time, if he reduces it, decides to charge 2 phones, and does not put on all the 5 bulbs at a time, what will happen to the runtime? The runtime will increase. And that is why I always advise customers that whenever you go solar, you make sure that any appliances that you are not using at that particular moment, put it off so that you can have an increased runtime for your solar system. So basically, that is how to calculate, that is basics of load analysis. So the next video, video 4, I'm now going to show you the design, the layout of the solar system using this particular example. I'll explain the parts, and then I'll explain how you can calculate your solar panel, how to know how many solar panels will be able to charge a 200 amp hour battery. Thank you very much for the time. I still remain Daniel from Blue Spark Innovations Energy Academy. I hope you liked the video and explanation. Please give us a thumbs up and like and subscribe to the channel. If you have any suggestions, just put it in comment section. And if you have a topic that is a challenge for you and you want me to explain more, just throw it there. I'll make a video on it. Thank you very much, and you guys have a nice time.